30,000 pounds of steel crashes into the ocean with thunderous force. Each link of chain weighs 136 pounds. And when a 100,000-ton aircraft carrier needs to stop, it relies on exactly 2 anchors. Not 1, not 3, exactly 2. And that number is not random. So let me ask you something. Have you ever thought about how an aircraft carrier actually stops and holds position in the ocean? Because I'll tell you right now, it's not what you'd expect. The USS Gerald R. Ford, the USS Abraham Lincoln, the USS George H.W. Bush. Every single American aircraft carrier has the same setup. 2 massive anchors. And the engineering behind them is absolutely incredible. Each anchor weighs 30,000 pounds on the Ford-class carriers. That's 15 tons, heavier than a fully loaded school bus. The anchor chain stretches 1,440 feet long, with a diameter of 3.5 inches. Every single link in that chain weighs 134 pounds. Think about that for a second. 134 pounds per link. But here's where it gets even more incredible. The older Nimitz-class carriers actually use even heavier systems. Each Nimitz carrier has 2 anchors weighing 60,000 pounds each. That's 30 tons per anchor. The chain diameter on these ships is 4.75 inches, and the links weigh up to 365 pounds each. When you add up one complete anchor and chain system on a Nimitz carrier, you're looking at 735,000 pounds of steel. Both anchor systems combined weigh nearly 1.5 million pounds. That's as much as 375 cars, just in anchors and chains. This massive weight isn't just for show. It's absolutely necessary to hold a 100,000-ton aircraft carrier in place against ocean currents, wind, and waves. So why exactly 2 anchors? Why not save money and space with just 1? And why not add a 3rd for extra security? All right, so let's start with the obvious question. Why can't a carrier just use 1 really big anchor? The answer comes down to redundancy and operational flexibility. If an anchor becomes damaged, broken, or lost, the ship needs to have another anchor that can be used as a backup. And this isn't just theoretical. Anchors can be lost. Chains can break. During severe storms, during combat operations, during emergency maneuvers, things can go wrong. There's also the issue of maintenance. It's important to alternate anchors to prevent unused gear from getting rusty and breaking easily. Captains can alternate anchors to ensure both remain functional and ready. A single anchor system creates a single point of failure. If that anchor drags, if the chain breaks, if anything goes wrong, the ship is adrift. And a drifting aircraft carrier is a disaster waiting to happen. But there's another critical reason. Ships carry anchors on both port and starboard sides of the bow. This symmetrical placement allows for strategic anchoring options based on conditions. With 2 anchors positioned symmetrically, you get balanced holding power. The ship can maintain a stable heading even in challenging wind and current conditions. So 1 anchor isn't an option. The risk is too high. The operational flexibility is too limited. If you learned something new today, show some love with a like and subscribe. It helps us tell more stories about the sailors who make this possible. So if 2 anchors are good, wouldn't 3 be better? Why not add a 3rd anchor for even more security? The answer is actually pretty straightforward. Some ships will have a 3rd backup anchor, but this may not be the full size or weight of the main anchors. So 3 full-size anchors are not standard practice. And there's a very practical reason for this. The problem with 2 anchors is that they can easily be tangled. Just one 360-degree swing at anchor will twist them up good. With massive chains weighing hundreds of thousands of pounds swinging due to changing wind or current, adding a 3rd anchor would increase the complexity exponentially. The risk of fouling, where the chains become hopelessly tangled, goes way up. There's also the space issue. The bow of an aircraft carrier is already crowded. You've got the anchor windlasses. Those are the massive machines that raise and lower the anchors. You've got the chain lockers below deck. You've got the hawse pipes guiding the chains. Each anchor system takes up massive amounts of space. A 3rd full-size anchor system would require significant modifications to the ship's design, and the operational benefits don't justify the cost and complexity. So 2 anchors is the sweet spot. Enough redundancy for safety, symmetrical placement for balanced holding power, manageable complexity for operations.
Now, here's something most people don't understand about how anchors actually work. It's not just the anchor holding the ship in place. There's something called the catenary effect. The catenary is the natural curve that a chain makes when it's suspended between 2 points, in this case, between the ship and the seabed. This curve is absolutely critical to how the anchor system works. When the anchor chain deploys, it doesn't go straight down. It creates this graceful curve from the ship's bow down to the anchor on the seabed, and this curve acts like a massive shock absorber. Think about what a carrier faces when it's anchored. Waves are pushing the ship. Wind gusts are hitting the island structure and flight deck. Ocean currents create constant pressure. All of these forces are trying to move the ship. Without the catenary curve, every one of those forces would be transmitted directly to the anchor. The anchor would be subjected to sudden, violent loads that could cause it to break free or the chain to snap. But with the catenary curve, the chain absorbs those forces. When a wave pushes the ship, the curve flattens slightly. When the wave passes, the curve returns to its natural shape. The chain is constantly flexing and adjusting, taking up the strain. The weight of the chain lying on the seabed is also critical. The Navy uses a specific formula, a deploy chain that's 5 to 7 times deeper than the water depth. So if a carrier anchors in 60 feet of water, they'll deploy between 300 to 420 feet of chain. Why so much? Because you need enough chain weight on the seabed to create the proper catenary curve and provide sufficient holding power through friction. The anchor itself might provide 30% to 40% of the holding power. The rest comes from the weight of the chain. With 2 anchors deployed, you're putting out 600 to 840 feet of chain total. That's a tremendous amount of weight creating friction on the seabed and forming 2 catenary curves that work together to hold the ship steady. This is why the Ford-class carriers can use lighter anchors than the Nimitz-class. The 15-ton Ford anchors versus the 30-ton Nimitz anchors. It's not about the anchor weight alone. It's about the entire system working together. So let me tell you about a historic moment that most people never heard about. March 15th, 2020.
The USS Gerald R. Ford conducted its inaugural anchoring evolution during an independent steaming event. This was the first time Ford used its portside anchor. Now, you might think, what's the big deal? It's just dropping an anchor, right? But remember, this is a brand new class of carrier with a completely redesigned anchor system. The Ford-class anchors are half the weight of the Nimitz-class anchors. The chains are thinner, 3.5 inches versus 4.75 inches. Everything about the system is different. So this first anchor drop was a critical test. Would the lighter system work? Would it provide enough holding power for a 100,000-ton ship? The successful port anchoring allowed greater flexibility for Ford in future sea and anchor evolutions, accommodating various sea conditions with additional maneuverability. Lieutenant Commander Jason Hinckley, Ford's first lieutenant, said, "Everyone in the forecastle to the bridge watch team who participated did an excellent job. The communication was great, and it gave our team a chance to remain proficient on a complex evolution such as this." This wasn't just about testing equipment. It was about proving that American engineering could make a carrier anchor system lighter, more efficient, and just as effective. And it worked. Want more carrier videos? Super Thanks keeps them coming. Appreciate you. Alright, so let's talk about what actually happens when a carrier drops anchor, because the process is both fascinating and terrifying. When an aircraft carrier approaches its anchoring position, the bridge gives the order to stand by. Sailors on the forecastle release all but one of the chain's stoppers. The windlass brake gets released, so the entire weight of the anchor rests on just one remaining stopper. Here's where the danger becomes real. With everyone standing clear of the chain area, a sailor uses a sledgehammer to knock loose something called a pelican hook. The moment that hook releases, the anchor plunges into the water with tremendous force. The sound is described as a great roar that echoes across the ship. The chain follows the anchor down with incredible speed and power. We're talking about 134-pound links moving at high velocity on the Ford, or 365-pound links on the Nimitz. This is why Navy safety procedures are so strict. A second sailor actually holds a safety strap connected to the first sailor's back. Why? Because if someone gets caught by that moving chain, they could be dragged overboard in seconds. Once the chain starts moving, stopping it becomes nearly impossible. The momentum of 30,000 to 60,000 pounds of anchor, plus hundreds of feet of heavy chain, creates forces that no human can control. The sailors who operate these systems know they're working with what they call a chained dragon. One wrong move, and it could drag a person overboard. When the anchor hits the seabed, it begins to dig in. The anchor's flukes, those are the triangular-shaped ends, are designed to bite deep into sand, mud, or rock on the ocean floor. The ship's captain then orders the engines to back down slowly. This backing motion causes the anchor's flukes to dig even deeper into the seabed, setting the anchor firmly. So let's talk about maintaining these massive anchor systems, because the work never stops. The chains face wear from friction against the seabed every time they're deployed. Salt water causes corrosion that weakens the steel over time. Navy maintenance crews inspect every link regularly, looking for signs of wear, cracks, or corrosion damage. Recently, the USS Nimitz made history by having its own crew remove and maintain the anchor and chain system instead of hiring civilian contractors. This was the first time an aircraft carrier crew had taken on this massive job themselves. It demonstrates the incredible skill and dedication of America's Navy sailors. The process of removing an anchor chain is a major operation. Each 90-foot shot of chain on a Nimitz carrier contains 57 individual links. Those 57 links weigh a combined 20,500 pounds. Sailors must carefully lift and move each section using specialized equipment and procedures. One mistake could result in serious injury or damage to the ship. Storage of these chains when not in use is another engineering challenge. Below deck, each carrier has huge compartments called chain lockers. These spaces must be large enough to hold over 1,000 feet of heavy chain, while keeping it organized for rapid deployment. The chain locker connects to the anchor windlass through the hawse pipe. The hawse pipe is a large tube that guides the chain from the storage area below deck to the anchor position on the bow. This tube must be strong enough to handle the tremendous forces when the chain deploys at high speed. So why does all of this matter? Why should we care about how many anchors a carrier has? The anchor systems enable carriers to respond quickly in emergency situations. If a carrier needs to establish a stable platform for rescue operations or disaster relief, the anchor system allows rapid positioning. This rapid deployment capability has proven crucial during humanitarian missions. After natural disasters, carriers can anchor offshore and use their helicopters to deliver supplies and evacuate injured people. The anchor systems also enable carriers to maintain stable positions during limited flight operations. Even small movements can affect aircraft launch and recovery operations. When conducting operations while anchored, the carrier must remain steady. The two-anchor system provides this stability, allowing the ship to maintain its position and heading. Aircraft carriers represent America's ability to project power anywhere in the world's oceans. The anchor systems are a critical part of this capability. They allow these floating air bases to establish temporary positions wherever they're needed, whether for combat operations, humanitarian relief, or diplomatic presence. The massive anchor systems of America's aircraft carriers stand as symbols of our naval strength. They demonstrate our ability to deploy, position, and maintain the most powerful warships ever built. Two anchors, one on the port side, one on the starboard side, working together to hold a 100,000-ton warship exactly where it needs to be. That number is not negotiable. It's not a tradition. It's the result of decades of engineering experience and operational lessons learned. It's about redundancy. It's about balanced holding power. It's about operational flexibility. From the 30-ton Nimitz anchors with 4.75-inch chains to the 15-ton Ford anchors with 3.5-inch chains, American engineering continues to improve these systems while maintaining the proven two-anchor configuration. The catenary effect, the symmetrical placement, the ability to alternate anchors, all of these factors combine to create a system that works. So the next time you see an aircraft carrier anchored off a foreign coast, remember those two massive anchors holding it in position. Remember the engineering. Remember the sailors who deploy and maintain them. Because those anchor systems are the reason American carriers can establish presence anywhere in the world. What impressed you most about carrier anchor systems? Let us know in the comments, and remember to like, share, and subscribe for more stories about the men and women who serve. Also, click the next video showing on your screen. You're going to enjoy it.